Hey there students, in this group we're going to be going over an example on how to graph quadratics using intercepts and the vertex. Alright, so the instructions for the example we're going to do, we're to graph the related quadratic function of the given quadratic equation using the intercepts and vertex. So let's take a look at example 1. Let's consider the quadratic equation 3x squared plus 4x, 3x squared plus 4x plus 3 equals 2. Okay, now to find the related quadratic function of this quadratic equation, we have to first write this in standard form. Okay, so to do that, we have to set it equal to 0 with the degrees in descending order. All right, so to accomplish this, we're going to have to subtract 2 from both sides. So we have it set equal to 0. So we'll have 3x squared plus 4x plus 1 equals 0. Okay, so that makes the related quadratic function f of x equals 3x squared plus 4x plus 1. Okay, we just set the quadratic in standard form equal to f of x. All right, now what we're going to do is find the intercepts and the vertex. How about we start off by looking for the um, x-intercepts. Okay, so let's write that down. X-intercepts. The x-intercepts are also known as the roots of your quadratic function or the zeros of the quadratic equation. Okay? Alright, so let's go ahead and look for the x-intercept. So to get the x-intercept, what we'll do is we'll set y equal to 0 to find the x-intercept. So we have 3x squared plus 4x plus 1 equal to 0 is equal to 0 because y is now 0. Alright, so let's go ahead and solve this. So to do that, we're going to use the factoring method. We can use completing the square or the quadratic formula, but let's try the factoring method first to see if it works, okay? So I'm going to use the AC method to factor this. AC is 3 because we can see that A is 1, A is 3, B is 4, and C is 1. AC is 3, and then B is 4. All right, two numbers that multiply to give you 3 and add to give you 4 are 1 and 3. Okay, so let's put that in the middle. We're going to have 3x squared plus 1x plus 3x plus 1 equals 0. Okay, so what we'll do now is we'll break it down the center and factor by grouping. Now from the first two, I'm going to factor out x. So let's factor out x from the first two. So we're left with 3x plus 1. And then from the next two, they are co-prime, so I can take out 1, 3x plus 1. Okay? And then to factor this completely, we have 3x plus 1. Those are the common factors of each quantity times x plus 1 equals 0. Now we're going to use the zero product property and set both factors to 0. 3x plus 1 equals 0, and x plus 1 equals 0. To solve this for x, we'll subtract 1 from both sides. We have 3x equals negative 1. And then to finish it off, I'll divide both sides by 3. And then that yields x equals negative 1/3. Alright, and then we subtract 1 from both sides to get the second intercept, x-intercept, and we have x equals negative 1. So our x-intercepts are going to be negative 1/3 and negative 1. Okay? Alright, let's go ahead and now look for our y-intercepts. Let's partition this workspace down the center, and then we'll look for the y-intercepts right here. Alright, so what are our y-intercepts? Y-intercepts are the y values that you get when you set x equals to 0. Okay? So the original function, we can write it as y equals 3x squared plus 4x plus 1. So in standard form, the y-intercept is always c. So we can clearly see that the y-intercept is 1 here, because that's what the value of c is. But if we want to work it out, all we do is we set x to 0, and you see that the y-intercept is going to be c. Because this first term is going to become 0 because this x is going to be 0. We multiply by 3, and then this second term will be 0 also, because when x is 0 multiplied by 4, you get 0 plus 1. And I clearly see the y, you clearly see that your y-intercept is 1. Okay? So there goes our intercepts that we're going to use. Next thing we're going to look for is the vertex. Okay? The x and the y coordinates of the vertex. So let's look for the x coordinate of the vertex first, since the y coordinate of the vertex is dependent on that. So to find the x coordinate of a vertex, we're going to use the formula negative b over 2a. Okay? Looking at the standard form of the equation of our function, we can clearly see that a is 3 and b is 4. Okay, so let's put that in this formula. So we're going to have negative 4 divided by 2a, which is 2 times 3. All right, this becomes negative 4 over 6. Divide top and bottom by 2, and then we'll end up with negative 2 over 3. Okay, so there goes the x-coordinate of the vertex. Well, let's find the y-coordinate of the vertex. That's going to be evaluated by looking for f of negative b over 2a. Now, what on earth does f of negative b over 2a mean? Well, that simply means what's the output when you input negative b over 2a into the original function. Okay? We already know what negative b over 2a is, which is negative 2 thirds. So we're looking for f of negative 2 over 3. Okay, so let's go ahead and evaluate this by plugging in negative 2 over 3 into the original function. All right, so the y-coordinate of our vertex is going to be 3 times, instead of x squared, we're going to put negative 2 over 3 squared plus 4 times negative 2 over 3 plus 1. This is what you get when you input negative 2 over 3 as your input for the original function. Okay, now to simplify this, we're just going to use the order of operations. All right, we're going to do with exponents first. So we're going to have 3 times negative 2 thirds squared is going to become positive 4 over 9. Plus, put this 4 over 1, multiply with that. So this plus becomes a minus. So we'll have minus 8 thirds plus 1. All right, let's see if we can reduce this before we multiply. 3 goes here, 3 goes here 1, 3 goes here 3. So this expression becomes 4 over 3 minus 8 over 3 plus, I want to express 1 with the same denominator as these two fractions, namely 3. So to accomplish that, I'll write this as a fraction, and I'll multiply top and bottom by 3 so that the denominator can be 3 also. Alright, so 1 over 1 is the same thing as 3 over 3. Now let's simplify this. This is 4 minus 8 plus 3 over 3. 4 minus 8 is negative 4 plus 3 is positive. Let's see, 4 minus 8 is negative 4 plus 3 is negative 1. So negative 1/3 is the y-coordinate of our vertex. So we're going to have the y-coordinate of our vertex be negative 1/3. So what is our vertex? Our vertex is going to be negative 2/3, comma, negative 1/3. Alright, so there you have it. Alright, so what we're going to do now is we're going to use all this information that we have to generate the graph of our function. We can clearly see that our vertex is in the 3rd quadrant, so we're going to make it sufficiently large. Alright, so let's make our coordinate system in the lower left corner. So let's break it down like this. Your x, the y, and your x-axis. I'm going to calibrate my x-axis by 3s because we have, if you look at my x values I'm graphing, namely the x-intercepts and the x-coordinate of the vertex as a 3 in the denominator, so we can use 3 as our calibration here, okay? So 3 tick marks is going to be 3, so 1, 2, 3, that's going to be a whole unit for me, okay? This will be, that's negative 1, negative 2/3 over here, and this would be negative 1/3. 0, and then that will be a third on the right. For the y calibration, we can use 3 tick marks to be 1, because if I look at the y's that I'm graphing the y coordinate of the vertex, which is negative 1/3, and I'm graphing the y-intercept, which is 1, and the LCD of 3 and 1 is 3. Okay, so let's go ahead and graph the points. So we're gonna have, let's graph the x-intercepts first. So our x-intercepts are -1 and uh, -1/3 and -1. So let's go ahead and graph that. So we have -1/3 right here. I'm gonna use green, so -1/3, and then -1, and then the vertex is -2/3 and one and -1/3. So let's calibrate our x-axis. How about we say 1, 2, 3 is 1. This is 1, and this is -1/3. All right, so our vertex is going to be right here, and then the x-intercept is going to be right there. All right, so I can clearly see the points, how it defines my graph. All right, so this one I went up 1, 2, 3 over 1, 2, so I can do the same here. 1, 2, 3 over 1, 2. It's just a symmetry, preserving the symmetry of our curve. Okay, so now we can graph the parabola through those points. Do that again. Graph your parabola through the points like that, and then the other piece like that. Okay. All right. Now let's go ahead and label our parabola. So, all right. So start by labeling the intercepts. So this is your y-intercept. This value right here is your x-intercept, and then this is your other x-intercept right here, x-intercept, and then this value this is your vertex. The vertex is -2/3 and -1/3. And then last but not the least is your axis of symmetry. Looks like right here is your axis of symmetry. And it's given by x equals the x-coordinates of your vertex, which is -2/3. Alright, so there goes the graph of your quadratic function using the intercepts and roots. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel. You can comment in the comment section to tell me what you think about this presentation. Click like if you liked it. And also feel free to share with your friends via your respective social networking program. Thanks again for watching, and have a wonderful day.